Let's go over a couple of strategies for solving quadratic equations. So those are equations that are equivalent to something of the form ax squared plus bx plus c is equal to 0, where a itself is not 0. In example 1, I want to use a factoring technique to figure out the numbers that make this true. And there's probably going to be two solutions, as we've seen before with some basic quadratics. The first step is to set this equation equal to 0 so we can use this above fact. If I subtract 2x and 15 from both sides, my equation becomes x squared minus 2x minus 15 is equal to 0. The next step is to figure out a way to factor this side of the equation. That is, we want to write it as a product. If we do this, we can look to see where each part of the product is equal to 0. So going back here, I want to somehow write this as a product of two linear terms. And I think this is going to be simple enough that we can just guess the factors. I know we have to have an x and an x because this is how you can multiply to get back to an x squared. I now need to choose a number that goes here and a number that goes here so that the product of the two numbers is equal to negative 15, yet when I add those two numbers, it takes me to negative 2. So let me write that off to the side. I want the product to equal negative 15, and I want the sum to equal negative 2. So if I look at this negative 15, I have to think of two numbers that would multiply to it since it has to be the product. There's choices like, maybe I'll just jot a couple down, like maybe it could be 1 and 15, where maybe it's negative 1 and positive 15, or 1 and negative 15. That's a possibility. We could have 3 and 5, I'll put the negative on the 5, or negative 3 and positive 5. And that is essentially it. So between, amongst those, there has to be one where when I add the two numbers together, it takes me to negative 2. And that is right here. If I sum these two together, I get negative 2. So what this tells me is I'm going to put positive 3 here and negative 5 here. Let's just check to see that this is true. X times x gives me x squared. This 3 times this negative 5 gives me the negative 15. And your two middle terms are going to be negative 5x, 3x, and that adds to a negative 2x. This is the factorization of this. But now, if I want to figure out where this equation is equal to 0, I can just look to each factor and see where those are 0. That is, where does x plus 3 equal 0? And where does x minus 5 equal 0? These are very easy equations to solve. You can just subtract 3 from both sides in the first one. You can add 5 to both sides in the second one. And here we have two solutions to this equation, negative 3 and positive 5. Just to point out, it'd be completely okay to look at this factor and say, if you plug negative 3 in place of x, it would give you 0 back, meaning negative 3 is the solution. Or here, I just looked at this and said, well, clearly if I put 5 in place of x, it makes this 0, so this has to be a solution as well. So you don't always have to write these equations out if you understand that. You could simply look at each factor and ask yourself, where is it equal to 0? So unfortunately, this idea of just guessing factors does not always work, especially if your equations become difficult. So that's why if you have a general quadratic equation, you can use this formula to figure out the solutions as well. So this thing is called the quadratic formula. If your equation is written exactly in this form, you can take the values a, b, and c, simply plug them in place of where they appear here, and simplify this thing to get your answers. I want to try that approach in this problem, where I'll identify what a, b, and c are equal to, and plug them in place of this thing. For starters, this equation is only valid if it is in this form, and currently I do not see an equal 0, so I have to rewrite this equation by adding 17x to both sides. So this is really 2x squared plus 17x plus 8 is equal to 0. I wrote it this way so I can see that a is the number in front of the x squared, which is 2, b is the number in front of the x, which is 17, and c is the number at the very end, which is 8. Once you have all of this, you can simply go to the quadratic formula. Any place you see an a, you'll put a 2. If you see a b, you'll put a 17. And if you see a c, you'll put an 8. Okay, this becomes negative 17 plus or minus. This is in the formula to indicate that there can be two potential solutions. We then get the square root of 17 squared minus 4 times a is equal to 2, then times c, which is equal to 8. And this is all divided by 2 times a, which is 2. There's not really much left to do except for carefully simplify this thing. So let's go through that process. Okay, we get x is equal to negative 17 plus or minus. I'm going to do the very next step completely in my calculator. I'm just literally going to type this statement in and see what number I get back. That is 17 squared minus 4 times 2 times 8. Okay, it gave me 225. So that is the square root of 225. This is all divided by 4. Continuing, we get negative 17 plus or minus square root of 225 is going to work out nicely. That's 15. And this is all divided by 4. So here we have two answers. We have to break it up into two pieces. We have x is equal to, it's negative 17 minus 15 over 4. And it's also x is equal to negative 17 plus 15 all over 4. So I'm just going to carefully simplify both of those numbers. So we have negative 17 minus 15 all divided by 4, and that is equal to negative 8. And then I have negative 17 plus 15, negative 2, and when I divide that by 4, I get negative 0.5, or you can leave it as a fraction and say negative 1/2. Both are completely okay, but these are the two solutions to the equation. So it depends on the equation you start with. It might be worth looking at it and saying, can I factor it? And if it's really simple, I would take a guess and check approach. But if you have a kind of, somewhat complicated equation, it might be worthwhile just going to this formula and going through the process that we have here. So let's try one more. We have x squared minus 2x is equal to negative 2. This one looks simple enough where I'm going to write it so it's equal to 0 by adding 2 to both sides. And it seems like maybe I could even take a guess and check approach, something like this. It's either going to work or it's not. In terms of what we talked about before, the product would have to be positive 2, and the sum that comes from those products is going to be negative 2. And I cannot think of anything that's going to work out nicely. I mean, I'd have to have x and an x. Oh, this is interesting. You'd have to have that both numbers are negative. This is the only way you can multiply to a positive number yet add to a negative one. And if you're going to guess something simple, your only options when dealing with a product that goes to 2 is going to be 1 and 2. But if you put a negative 1 and a negative 2 here, that adds to negative 3, which doesn't match up with negative 2. It doesn't mean that there aren't solutions to this equation. It could be the case, but what it does mean is I just can't guess the answers, and so I'm going to abandon this approach. So unfortunately, this really did not work out very well for me. I'm now going to go to the quadratic formula and note that a is equal to 1, that's the number in front of the x squared, b is equal to negative 2, and c is equal to positive 2. Let's plug this into the formula and see what happens. So the formula was negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times 1. All right, let's carefully simplify this thing. negative 2 is positive 2, plus or minus, okay, now we have the square root of negative 2 squared is 4, minus 4 times 1 times 2 is 8, all over 2 times 1 is 2. So that means x is equal to 2 plus or minus the square root of 4 minus 8 is the square root of negative 4 all over 2. At this point, the solutions they're not going to be real. I know if you take the square root of a negative number, if you type that into your calculator, it'll give you an error message. But we talked a little bit about complex numbers. Let's take this further. I'm going to write this as something in terms of an imaginary number I, just to continue this process. So by that I mean x is equal to 2 plus or minus, all right, the square root of 4 is 2, and the square root of negative 1 is I. And this is all being divided by 2. That 2 gets divided into both terms of the numerator, right? This is 2 over 2 plus or minus 2i over 2. And that is 1 plus or minus I. These are the solutions. There's two of them. We get that x is equal to 1 plus I, but we also get that x is equal to 1 minus I. That's why we couldn't really guess the answers, because the answers were not integers. They were, in this case, complex numbers. There are no real solutions to this equation, but it is okay to write your answer in terms of a complex solution. And just note that they're not real answers. You could technically say there's no real solution. However, you can continue this process a little bit to get these values down here.